Excuse me. Hey, shush. Okay, so 11:55. Let's continue with chapter 9. We have 1 hour to go. Okay, let's do our best to cover as much as we can. Okay, so chapter 9 talks about simple harmonic motion and waves. And we are going to talk about simple harmonic motions, simple harmonic motion of a spring mass system, mechanical waves, the wave propagation, and wave equation. So for this chapter, I believe it's, okay, chapter lain pun heavy on maths juga. Tapi yang ni, dia memang banyak maths lah, okay? And graphs. Okay, so the learning outcome for this chapter is to explain and solve problems on simple harmonic motion, explain mechanical waves, explain wave propagation in the medium, and use the wave equation. Okay. Next, the motion of a particle. We know that we have translational. We also, where the object moves over a specific path. You have linear, which is free fall motion. You also have parabolic, which is a projectile motion. You also have circular, orbital Earth, orbiting the Earth, moon orbiting the Earth. You also have motion of a rigid body, rotation, rotating fan, rotation plus linear rolling wheel. So kita dah belajar all these motions, motion of a particle and motion of a rigid body. Okay, so banyaklah motion kita belajar. Okay, next. So now we are learning a new type of motion. Tadi kita belajar rigid body, equilibrium, non-equilibrium, orbiting, so on. Now we have oscillation. What is oscillation? Oscillation happens when an object vibrates or oscillates back and forth over the same path. Okay, over the same path. Okay, kena same path. Ni keyword dia. So I have a pendulum. It moves from point A to point B over the same path. If let's say I come, this is me, okay, I want to disturb the pendulum, so I apply a force. So now the pendulum goes to point C. Now it's not a simple harmonic motion because it is not in the same path and it's not repetitive anymore because I disturbed it, right? Simple harmonic motion kena sama path from A to B, B to A to B, B to A, and it is repetitive. Periodic motion with constant amplitude. So here kita assume it is an ideal system where the motion tu sama, dia punya speed tu sama. Yes, the speed is the same in the ideal world, right? In the ideal world. However, we don't live in an ideal world. So the speed decreases over time because the energy decreases, right? Kejap Okay, so in the real world, we have damped harmonic motion. So that is why your clock has batteries to keep it at the same speed. Okay, if it doesn't, if you just rotate it, if you just apply a force and you expect it to swing back and forth until the end of time, it's not going to happen. Okay, because it loses energy in the form of many types of heat or vibration or whatever lah. Because our world is not ideal. However, simple harmonic motion, kita assume that we are in ideal situation, the path is the same, and it does not decrease in amplitude. Amplitude speed ke apa-apalah, tak kisah. Okay, so it is constant like that. And then we have waves. Waves is oscillation plus linear motion. Okay, it oscillates and it also moves forward. So here you can see that it has oscillation, ni macam ni. It also moves forward. So that is waves. Because simple harmonic motion, the object vibrates or oscillates back and forth over the same path and distance, each cycle taking the same amount of time. Kena repetitive, It has to be repetitive. Repetitive over same path. That is the condition for simple harmonic motion. Okay, for example, I have a spring in an ideal world. I will tarik from its equilibrium. Ni equilibrium maksudnya saya tak apply stretching force lagi, saya tak tarik dia lagi, or saya tak compress dia lagi. This is the equilibrium. Now I stretch it. Kejap. Okay, so each cycle taking the same amount of time. Okay, so kita back to the spring. So this spring is in equilibrium, and then I apply a stretch. I stretch the spring. Okay, so I stretch the spring. What happens is that, so I stretch kat sini, this is point A. What happens is that it will go here to A as well. Dia akan pergi sini. Okay, so I stretch. It goes here. Then it goes here, then it goes here, and then it goes here. So that is the oscillation. It oscillates back and forth. Okay, assuming that it is in an ideal situation. So this oscillation will not decrease in amplitude or will not decrease in the displacement. So here, the displacement from the equilibrium is called amplitude. Okay, so this is positive A, this is negative A. Again, I'm going to repeat myself. When I stretch it, I displace the spring from an equilibrium by a distance A. By distance A, right? This distance A is called amplitude. And what happens is that it will oscillate from here, from point, kita pakai point lain lah, kita pakai small a. It will oscillate from small a to B, and then B to A, and then A to B, B to A. Okay, from the equilibrium position to B is minus A. The displacement is still A, but because it's in the left direction, it is negative A. Okay, so this is the first term that we are learning, amplitude. Okay, that is amplitude. The same case if I have a spring that I stretch down, this is the equilibrium. Okay, I stretch it down by a certain distance. So that is my A. So if I want to say going down is negative, I can say this is negative A, and going up the same distance, the same distance. This is distance A. This is also distance A. This becomes positive A. So the spring oscillates from positive A to negative A to positive A to negative A to positive A to negative A. If you try it yourself, you can see that it will go up, go down, go up, go down. It will not just stay at the equilibrium after you stretched it, right? It will go up above the equilibrium. Kalau dia patah balik pun, dia tak patah balik ke equilibrium. Dia pergi patah balik dekat positive A. So the total displacement daripada bawah yang you stretch tu is 2A actually. So it oscillates from negative A to A, negative A to A, negative A to A. So that is your simple harmonic motion. Sama juga macam pendulum. You start at equilibrium. This is your equilibrium position. You tarik, what do you call it? You pull it by a certain distance. That is also A. And then let's say this is positive A. It will swing to negative A. Positive A, negative A, positive A, negative A, positive A, negative A. That is your simple harmonic motion. Okay? Okay, so here they tried to map out oscillation. Okay, so we have a lamp here, right? So ni lampu, lampu punya light. So this is the this is the oscillation. When the turntable rotates with a constant angular speed, the shadow moves in a simple harmonic motion. Okay, so for a clock, since it rotates from here to here, here to here, here to here, it is repetitive over the same path. That is also simple harmonic motion. But they want to map it out to make it look like a spring so that, okay, sama tak macam simple harmonic motion spring? Sebenarnya sama. So here, remember that we have our spring goes from positive A to negative A, positive A to negative A. So here, they mapped out the shadow of this particle, oh no, not of this particle, of this hand clock. Okay, hand clock ni ada particle lah. Okay, let's just say we are mapping the particle. So the particle punya shadow tu rupa dia sama macam the spring when it goes back and forth, back and forth. So here, walaupun rupa dia lain, walaupun it looks like a clock, even though it's rotating in a circular motion, it is also a simple harmonic motion. It satisfies the repetitive over the same path. And when you map it, using the shadow punya setup, it looks exactly like the spring. Okay, so that was the experiment. Here, tadi tu diorang tunjuk the shadow from upwards. So this is the light, so it goes, so the light was here, so the shadow is down here, right? Shadow. Here the light is this way, so the shadow is this way. Diorang nak tengok juga. Tadi diorang tengok with respect to x-axis. Sekarang nak tengok with respect to y-axis. Sama juga, it's still simple harmonic motion. Okay, so simple harmonic motion ni ada x displacement, ada y displacement. We will also look at this later. So the amplitude A is the maximum position of the object relative to the equilibrium position. What this means is we have a spring, kita ada equilibrium position. This is the maximum displacement. That is your A. Okay, I told you it goes from positive A, negative A, positive A, negative A. So the maximum displacement from the equilibrium is A. That is called amplitude. And the period is T. We have learned T in chapter 7. And chapter 7 is the time for one cycle of motion. What is one cycle of motion? When it comes back to the same initial position, comes back to, how do I write this? Comes back to initial position. Sorry lah, singit-singit. So imagine the clock. If I start from 12 o'clock, one cycle is back to 1 o'clock. That is your one cycle. One cycle, let's say it takes 12 hours to reach 12 o'clock, right? 12 hours to reach 12 o'clock again. 12 o'clock. Turut terusan. Okay, 12 hours to reach 12 o'clock. So your T is 12 hours. Kenapa macam lagging? Sekejap. Okay, T is the time taken to reach one cycle. What is one cycle? One cycle is the path from the initial back to the initial. Okay, kalau spring pula, okay, lagging lah. Tulisan saya jadi buruk, lagi extra lagi buruk lah daripada biasa. Where's my equilibrium? Okay, this is my equilibrium. I stretch it, so it starts from here. This is my initial lah, contohnya. Equilibrium. This is my initial. I start from rest here, V equals to 0. This is my initial lah. Saya declare initial start pada situ. So one cycle is going here, go back here. One cycle. Woi, kenapa dia macam tu? Sorry, terjerit pula. One cycle, right? I am from here, I go here, and then I go back to the same place, one cycle. Sama juga, if I have a spring yang upward macam ni, yang vertical, upward pula. Vertical, I stretch it. Let's say this is my initial position. So this is my initial. It oscillates, it goes up, and then it goes down again, one cycle. Okay, it has to go back to its initial position to complete one cycle. Okay. Okay, so frequency is 1 over t, 1 over period. Okay, so angular frequency is given by 2 pi f or 2 pi over t. We've seen this before. You've seen this equation. Radian per second. 2 pi is radians. It takes 1 revolution. Sorry, omega is the speed to complete 1 revolution, right? So the speed to complete 1 revolution is 2 pi radians, the displacement over the time for 1 revolution. So 1 revolution is 2 pi, time for 1 revolution is t, period. Okay, so 2 pi radian over t. So it's 2 pi over t or 2 pi f because f is 1 over t. Okay. The angular displacement is 2 pi radian. We can define as, okay, right? So angular speed is this angular displacement over time. And the displacement equation for a simple harmonic motion is A, which is the maximum displacement. You could also call it amplitude. Okay, let's just call it amplitude from now on. And you have sine theta for the y. Theta is also equal to omega t. Why? Because I just put the t next to the omega, it just becomes omega t equals to theta. So this guy is interchangeable. You can say a sine theta or a sine omega t. Boleh juga. Okay, but most of the time, you will use this equation. Okay, because they like to deal in angular speed. This is for y displacement. Ya, ini equation displacement tau. So y equals to the maximum displacement or amplitude sine theta. Kalau x displacement, this is x, maximum amplitude cosine theta. Cosine, x is cosine, y is sine. And then you can also write it as a cosine omega t. Okay, so y displacement is this guy. X displacement is this guy. They map the rotation, the rotating particle. So the displacement in X is given down here. This is the X displacement and the Y displacement is given over here. Okay, so this is the equation. This is the equation. Okay, so kenapa, okay, I shouldn't say kenapa lah. So a simple harmonic motion can be described as a sinusoidal wave. So simple harmonic motion can be described as a sinusoidal wave. What is sinusoidal wave? It just means sine or cosine theta. Sinusoidal means something like that lah. SHM can be described as a sinusoidal wave, which is why when we write the equation for displacement y, we use the sinusoidal punya equation lah, sine. And x point, we also use cosine theta because it's just how it is. So we will see how that looks like in the graph form later. So here, y equals to a amplitude sine omega t. X equals to a amplitude cosine omega t. What is omega? Omega is the angular speed. T is time. Okay, next. So this is the sinusoidal nature of simple harmonic motion. This experiment shows the sinusoidal nature of SHM. The spring mass, okay, so this is a vertical spring. They try to map out, okay, kiranya macam you have a string and then you attach a ball to the spring and then what you did, how you map it is you attach a pen to the ball, right, to the ball. So each time the ball swings up, swings down, swings up, swings down, because it is in simple harmonic motion, the pen writes on the paper. So when they try to map out, it looks like a sinusoidal wave, right? This is a sinusoidal wave. So they said, oh, so this SHM can be described as a sinusoidal wave. That's how they came up with the equation. Okay, tadilah dia suka letak equation tu because they found out that it looks like a sinusoidal wave. So that's it. They said, okay, mathematically we can describe the spring punya oscillation as sinusoidal wave. Okay. So this is how it looks like. So for X displacement, this is a displacement time graph. If they ask you to draw a displacement time graph, you should label the axis. This is time in seconds or just S, boleh juga. Okay, so this is a displacement time graph, which is the same as this equation. So this equation is X equals to A cosine omega T. For a cosine, when the theta or the omega T is equal to 0, your cosine is 1, right? Your cosine becomes 1, which means that your X becomes A. So here, when T is 0, your X is A. Okay, here is one cycle. Kejap. Cuma nak cerita lagi ni. Okay. And then one cycle is when you come back to your initial position. So where is the initial position here? You start from this point. Is this initial position? No, not yet. Are we at the initial position? Not yet. Here pun bukan. Here pun. This is the initial position. Why? Because if I cut this graph over here, it will be the same as the previous wave. Kat sini sama dengan sini. So this is one cycle. This is also one cycle. Why did I say this is the initial position? Because it comes back to A. Dia patah balik ke A. So kalau kita punya spring tadi, kita start dari A to negative A. So this is our initial. So it oscillates here and then it oscillates here. It comes back to A. So here it comes back to A. So that is your initial, right? So that is one cycle. Sama it maps out in mathematically. This is how it looks like. Okay, so A is your amplitude. That is the maximum displacement. Negative A is also your maximum amplitude, but in the other direction. So it's a negative A. One cycle is when you reach the same position. If you oscillate from A, you should reach balik A to get one cycle. Okay, so how do you know if it starts from A or if it starts from negative A or it starts from 0? Look at your equation. Plug in your T equals to 0. T equals to 0 gives you cosine 1. This equation becomes A. Okay, let's look at equation Y pula. At T equals to 0, your equation becomes 0. So your Y starts at 0. This is your initial point. So this is your sine equation. This is your cosine. Okay. So for this guy over here, one cycle is when I reach 0. When I reach 0 amplitude again. So when do I reach 0 amplitude again? I reach it here. Okay, sorry. Kat sini pun ada. But yang ni dia naik ke atas. Macam mana nak cakap ni? Macam mana saya nak cakap yang ni one cycle? Okay, so if I cut it here, one cycle, I assume this is one cycle. Is it the same as this one? No, it's not, because SHM kena repetitive over the same path. So here, if I say this is one cycle, it's wrong. It's not repetitive. So when does it become repetitive? It becomes repetitive when I cut it here. So this is one cycle. This is also one cycle. It becomes repetitive if I cut it here, right? If I cut it here, it's not repetitive because the other side is going upwards. Yang sebelah sini ke bawah. So it's not repetitive, so tak boleh lah. But if I use this whole thing as my one cycle, then it becomes repetitive. So this is also one cycle. Okay, so X starts from A. Y starts from 0. Yep, question? No question?
No question.
Okay. Okay, so tadi kita tengok equation untuk displacement sahaja. Apa itu displacement? Kalau kita tengok spring, pergi A, pergi negative A. Itu displacement, maximum displacement. So amplitude is displacement. Equation is x equals to A cosine omega t. Ataupun y equals to A sine omega t. Apa beza x dengan y? It's just your axis. If you have a spring that is in the x direction, use the x equation. If you have I shouldn't say vertical. Okay, tak apa. Nanti kita tengok yang lain. So x punya displacement is like that. Y punya displacement is like this. So the velocity, we know that velocity from previous chapter, we know that it is dx over dt, or the derivative of x, right? Do you call it derivative? Yes, derivative of x. So the derivative of x, or the differentiation of x, is cosine. When you differentiate it, it becomes negative sine omega t. And then you have to, okay, kita differentiate with respect to t. Differentiate it with respect to t gives me negative sine omega t, and then gonna differentiate what is inside here. So I get negative omega. Okay. So saya baru differentiate cosine je. My a is a constant. So my equation becomes negative a omega sine omega t. So that is the V equation. I don't know if you've learned this one before, this one yet in maths class. Saya tak tahu nak ajar differentiation ni macam mana. Saya tak pandai. Korang belajar tak? Tak belajar ke tak ingat? So d dt of cosine omega t, the differentiation of cosine omega t with respect to t is minus sine omega t, and then I differentiate what is inside here, bawa keluar omega kat sini. Sekejap. Differentiate over here. Okay. So this becomes minus omega sine omega t, right? Saya baru differentiate cosine. This guy is still there. So what should I do? Constant, when we differentiate, okay, I mean, I don't have to differentiate a, right? Because it doesn't have t. So your V becomes, a times minus omega sine omega t, which is how you get this equation. Okay, negative a omega sine omega t. Okay, now that's my best effort on teaching you differentiation. Saya tak pandai nak ajar math. Okay, so sama juga, acceleration is the differentiation of dv, is the differentiation of v with respect to t. Okay, sama juga. Differentiating sine gives you cosine. You differentiate what is inside. You have to take out the omega. So, sekejap, saya tulis kat sini. D dt of sine omega t, okay, differentiating sine omega t with respect to t gives me cosine omega t, is a positive, tadi tu negative. It's negative, cosine omega t, and then I have to differentiate the inside of this angle because ada t kat situ. So this becomes omega. Okay. I still have the minus a over here from v. So the minus a stays, is a constant. And then, sorry, I have this. So omega a minus a omega. And then multiply with this guy that I just differentiated. Omega cosine omega t. So it becomes a omega squared cosine omega t. A cosine omega t looks exactly like x, right? X is a cosine omega t. So saya boleh cakap macam ni. Omega squared minus omega squared x is my acceleration. Okay, you don't have to derive it. You can just memorize it. Just showing you, if you want to derive it, you can. Okay, so paling senang kat sini, ingatlah kena memorize. So A is minus omega squared X or minus omega squared A cosine omega T. This is your equation for V. Okay. Sama juga macam Y. Y juga pun kena differentiate juga. So sine differentiate sine with respect to T gives me cosine positive. That's why dia tak ada negatif kat sini. Okay, yang lain semua sama. Differentiate cosine with respect to time gives me negative sine. So that is how you get negative here. Okay. Sama juga equation A is minus omega squared Y. Senang cerita hafal je lah. But if you want to derive boleh juga.
Doktor,
Yep.
contohnya kan dia kan negatif apa tu omega 2x. Let's say kalau x dia tu negatif and then negatif positif. So which means untuk acceleration dia anti clockwise lah kan. Dia tak effect sign.
Itu dalam rotation how do I say this? Does it become anti-clockwise? Let me think. So it's
Tapi yang ni kan acceleration not angular acceleration alpha. So
betul? Untuk this chapter we will see acceleration tu dalam bentuk graph je. So dalam bentuk clockwise ke anti-clockwise ke, I'm not so sure. Saya tak pernah imagine pula in that sense. Just get back to that. Okay, hopefully I can find out the answer. So this is the graphical representation of a sine function. So sine is y, right? Y, this is your equation for displacement. A sine omega t, right? General equation, okay, kat sini pun ada. Y equals to A sine omega t. And so this is the time, sorry. This, dia tak cakap pasal displacement or anything. It's just with angle. Angle time. Okay, tak apa, kita tengok je. Okay, so y equals to A sine theta. So y is 0 at when theta is equal to 0. And then at 180 it's also 0, at 360 is also 0, 540 is also 0, and so on. Just nak tunjuk je how you map it out. At this guy is 90 degrees, so when theta is 90 degrees, sine becomes 1. So that is where you become A. Sebenarnya dia nak tunjuk tu je lah, dia nak tunjuk how the function, the sine function looks like on graph. Okay, so I think you know this already. So sini dia map out when it is in degrees. This one dia map out when it is in radians. So you know this, 180 is just pi, and 2 pi is one complete cycle or one complete revolution, which is 360. Okay, so if they ask you to plot it in terms of degrees, you should use degrees lah. But if they ask you to plot it in terms of radians, use the pi. If they ask you to plot it in terms of omega t, you plot it in terms of seconds. Sebab omega ni constant. Omega is a constant for simple harmonic motion. Okay, the omega is assumed to not it's an ideal oscillation, right? So the speed is almost always the same in an ideal situation. So you map out, if they ask you to plot with respect to omega t, you plot it with respect to t, seconds. Sorry, kenapa dia pakai t? Kenapa dia pakai t? Kat sini omega t. They should say it's t period. T period in seconds. Okay. Okay, this is the representation if you have x, v, and a. So x is a cosine omega t. So cosine, you know it starts from a and so on. Okay, you know how it looks like. And then v, your equation becomes a sine. Sine at when t equals to 0, you start at 0. And then, so this is what you do. So if you want to know how to map this, basically what you have to do is you have to plug in the angle, or you have to plug in the degrees, you have to plug in the radian, or you have to plug in the time. Kalau tak ingat bentuk dia macam mana. Okay, senang je, pakai equation. Ingat equation, plug in the values, plot it. Okay, sama juga. And then acceleration, we have negative omega squared A. So this is your amplitude now. This is now your amplitude or maximum displacement. Okay, tadi ni, this is your maximum displacement. This is your, this is also your maximum displacement for your V. So maximum displacement ni tak semestinya A. It is whatever is in front of your function, of your cosine or your sine function. So this, for X, your amplitude is A. For V, your amplitude is this whole thing. For acceleration, your amplitude or the maximum displacement is minus omega squared A. So this is how you see kenapa dia punya displacement is omega squared A. Yang ni omega A. Yang ni just A. So amplitude depends on your equation. It's not constant. Amplitude untuk graph. Okay, tapi amplitude untuk kita punya apa yang kita tengok kat spring tu is just X. We only see displacement. We can't see velocity, right? Our brains are not programmed to see velocity. We are only seeing displacement. So what we are seeing is it goes from A to minus A. Right? It goes A to minus A to minus A. So this is what happens. A to minus A to minus A. But if you are plotting the velocity, the amplitude becomes omega A. And if you are plotting acceleration, you are plotting the amplitude omega squared A. Tu je, kena ingat yang tu je. Lain, amplitude dia lain. Okay. Yes, equation. Soalan? Macam tak betul lah.
Doctor, I want to understand about the previous slide.
The previous slide, yep.
I'm not understanding why the graph is like this and the doctor explained to particular and practice.
Lagi sekali ni Izan, saya tak dengar.
I don't understand why the graph is like this and doctor explained too fast. I can't catch it.
Kejap, saya nak kuatkan lagi. Okay, again, sorry Mason, sorry, third time.
I don't understand why the graph is like this. And doctor explained too fast just now. I can't catch it.
You don't understand why the graph is like this when?
And doctor explained too fast just now. I can't catch it.
Last part tu saya tak faham. Ada apa nak cakap? Can you type it, Mason? Sorry, saya memang tak dengar langsung yang hujung-hujung tu.
Okay.
Chat. Where's my chat? Where is chat? Okay.
Doktor, tajuk ni masa final kan?
Masuk. Excuse me. Oh, sorry, doctor. Explained too fast. I can't catch it. Okay, so let me repeat myself. Okay. Excuse me. Okay, so we have learned that we have two equations. Y equals to A sine omega t. We also learned that X equals to A cosine omega t, right? Okay, X is A. A is your amplitude or the maximum displacement. Okay, maximum displacement. And omega is your speed of the oscillation. And t is just time lah. Okay. So tadi kita dah belajar differentiate V and A. Okay, so equation V untuk X is minus A omega sine omega T. Kita differentiate ni ya, kita dapat yang ni. And then for acceleration, our equation is omega squared X or A cosine omega T. Okay, sama kat sini pun ada 1%. So this is what we had after we differentiate, right? Okay, so previously I told you A is your maximum displacement. Okay, kenapa? Because when we have a spring, and this is the equilibrium position, equilibrium displacement equals to 0. Okay, equilibrium displacement equals to 0. When I stretch it, this is A, maximum displacement. It will move back and forth from positive A to negative A. Dia akan pergi ke kanan, lepas tu pergi ke kiri, pergi ke kanan, pergi ke kiri, because it has to be repetitive over the same path. Kita tahu, okay, just imagine the spring, it goes back and forth, back and forth, back and forth, right? Same path. So that is the maximum displacement. The maximum displacement is A. Sebab tu je yang saya stretch. I stretch it by A, that is your maximum displacement. Now, when we differentiate V, when we differentiate X to dapatkan V, our amplitude changes. I'm not talking about the amplitude over here. I'm talking about the amplitude of the graph. Kita nak plot equation ni dalam graph. So the amplitude for the graph, ini amplitude dalam real world. Amplitude dalam graph is dependent on the equation. So amplitude untuk V is minus omega A. So that is why it can move from negative omega A to positive omega A. Negative omega A to positive omega A. Because why? Dia repetitive over the same path. If the punya amplitude is negative omega A, it will also go to positive omega A. And then go back to negative omega A to complete one cycle. Then go back to positive omega A. So this is the amplitude kalau kita plot velocity. I'm not talking about the amplitude for this spring over here. The amplitude for this particular situation is displacement only. Right? Apa yang kita nampak is just displacement. I cannot see what is the velocity, right? I can also only see the displacement. But we can plot the velocity in terms of graph by looking at this equation. Okay, so the amplitude is minus omega A, and the bentuk graph dia is sine. Okay, so sine bentuk dia, it starts from 0 to negative, so like that, right? It starts from 0 to sine biasa. This is a normal sine omega t. Now it's a minus omega A. So dia akan terbalik lah sebab dia minus. Dia start from a minus. So dia akan jadi macam ni instead. So what is the amplitude? It is, sorry terbalik-terbalik semua, minus omega A. What is the maximum amplitude over here? It is omega A, which is over here, exactly the same. Graph dia, sign yang terbalik sebab negatif. Okay, is that clear? Okay ke Mazen? Mazen, are you okay? Okay, I lost Mazen. Okay, and then sama juga macam acceleration. I differentiate this velocity equation and I got this as my amplitude. So if I want to plot it in a graph, my amplitude goes from minus omega squared A to positive omega squared A. Sebab apa? It's a repetitive motion. Kalau dia pergi ke negatif, dia akan pergi ke positif, and then negatif, positif, negatif, positif. The function of this equation is a cosine. And kalau cosine biasa, cosine yang biasa, this is 0, cosine biasa akan start this is the maximum. Dia akan macam tu kan. But since this is a negative, dia akan terbalik, which is what is going on here. terbalik. Saya tak pernah nak lukis. Let me use this. The terbalik. So it starts from negative. Apa amplitude maximum dia? Negative omega squared A. How did I know this? From the equation. Okay. Part velocity and acceleration. Unfortunately tak boleh nak tengok dekat spring. Okay, you kena tengok equation. Okay, any questions? Was that okay?
Okay, thank you, Doctor.
Right. Okay, moving on. Okay, tadi kita plot with respect to, okay, we know that one cycle is 1 period, right? So this is T equals to 1 period. Sama juga, this is half period. Macam mana? Okay, yang ni apa beza dia? Kejap. What's the difference here? Oh, it's telling you the maximum. Okay. So here the displacement of X is positive A to negative A. Tapi kalau soalan tanya what is the maximum displacement, is just A. Okay, so here at the maximum displacement A, the velocity is 0 and the acceleration is negative A omega squared. Here, when the displacement is negative A, the velocity is 0, the acceleration is positive A omega squared. So, benda ni berkait lah, okay? Tu je nak cakap. Dekat maximum displacement, V is 0, acceleration ada value. Kalau dia punya A positif, dia punya acceleration negatif. Dia terbalik. Okay, and V is 0. Okay, X is 0 when, now it's saying X is 0, the displacement is 0 at T over 4. Maksudnya period divided by 4, and then 3 over 4 of a period, 5 over 4 of a period, and so on. And V is 0 when T is over 2. So basically just use this equation to find out when it becomes a 0. You don't have to memorize this, you just solve the equation. Okay, so let's do this problem. Particle performing a simple harmonic motion with a maximum speed. Okay, so this is V max 2.75, takes 0.5 seconds to complete a cycle. What is 0.5 here? It is the period. T equals to 0.5 seconds. Calculate its frequency, amplitude, and maximum acceleration. Okay, so how do we do this one? Okay, so we know that T is related to frequency, right? So frequency is 1 over T. The unit for frequency can be 1 over second or hertz. Both are acceptable. So frequency becomes 1 over 0.5. That's easy peasy. 2 hertz. That's your first one. What is the amplitude? So here, let's imagine the particle performing a simple harmonic motion. Okay, so a particle performing a simple harmonic motion. Boleh buat rotation, boleh buat back and forth, but let's do the rotation. Okay, because this one is easier. So particle selalunya akan berkait dengan rotational circular motion lah. Particle berkait dengan rotational motion. Spring berkait dengan linear punya displacement, back and forth, back and forth. This one, when it talks about particle, you use the circular motion. Okay, so here it says V equals to 2.75. What is the equation for V? What is the general equation for V? Anyone?
Negative omega is sine omega.
Negative A omega.
No, equation, not the one that we just learned.
U plus AC.
Okay. Lagi general daripada tu.
Displacement over time.
Displacement over time. Oh my god, you guys have so many equation. Betul, semua betul. Times pula dah, time, right? Displacement over time. So how do we relate it back to this particle? So the displacement that this particle makes over time. What is the displacement for one cycle? It is 2 pi r, because that is the circumference, that is the path that the particle takes to complete one cycle. And then one cycle takes 0.5 seconds, right? 2 pi r over 0.5 seconds. This is radian. Gives me V, but this V is linear. So how should I change it? No one? Okay, so
V over R equal to omega.
V over R equals to omega. Okay, boleh. Okay, jap. Here, what I failed to remind you is, saya yang tersilap, saya lupa nak cakap. When we have a motion, particle in motion yang circular macam ni, do we have it? Okay. VA, okay, so tadi kita cakap pasal simple harmonic motion. This guy also has simple harmonic motion, right? And the A is actually the radius. Saya lupa nak mention. The A is actually the radius. The amplitude for a particle in motion is the radius. So, kita masuk balik equation tadi. Okay. So this is displacement. Sorry, we are talking about distance, not radians. Saya silap. So 2 pi A. Because why? The radius is A. How did we know this? Because when we mapped it out, the simple harmonic motion, this is equilibrium, this is A, this is minus A. So the A is equal to the radius. Radius. Okay. Tadi kita nampak tadi. So here, your V is displacement over time. The displacement of this particle is 2 pi A, that is the circumference. And the time taken to complete one circumference is 0.5 seconds. 2.75. So here kat sini ada radians tau. Kita cakap pasal displacement. Saya tersilap. Okay, so 2.75 times 0.5 divided by 2 pi will give me the amplitude. Okay, it's not intuitive, I know. But that's why we are doing it. 2.75 times 0.5 divided by 2 pi. So the answer is 0.22. What is the unit? We are talking about the velocity is in meter per second. So this is also in meter. Amplitude ni displacement kan? So it is in meter. Okay, so that is your amplitude. The amplitude is 0.22. Okay, so maximum acceleration. Okay, how do I do this one? Maximum acceleration. Now we can use the equation yang kita belajar tadi, which is A equals to apa tadi? Minus omega
Square.
minus omega squared x, or minus omega squared A cosine omega t. Or struggle ni nak ingat. Okay, right? Okay, so what do we do next? So the maximum, when does x become maximum? X is displacement, right? When does x become maximum? When does A cosine omega t becomes maximum? What is the maximum value of cosine?
90.
No, what is the maximum value of cosine omega t? It's 1, right? 1. So the maximum x is actually If cosine is 1, that is the maximum for a cosine. The maximum for x is a, right? The maximum displacement of x is a, which is the amplitude. We already talked about this. So a max, acceleration maximum is minus omega squared maximum x or just a, right? So this equation becomes a maximum minus omega squared a. We know what omega is because we have v. So that is v equals to r omega. So that is 2.75 divided by r, which is, no. What is omega? We know what a is. A is 0.22. What is the omega? It's 2 pi 2. Why? Kenapa saya letak 2? Kejap. Oh, sorry. It's 2 pi f. Omega is 2 pi f, guys. Forgot. 2 pi f squared. And this is a. Right? Omega is 2 pi f. We already know the frequency. Okay. So that becomes minus 2 pi 2 square the whole thing. A is 0.22. So A maximum should be positive sebenarnya. So A maximum oscillates from negative to positive to negative to positive. But your final answer should be a positive when you are talking about A max. Okay. So that becomes 34.74. Oopsie. Meter per second squared. Okay, let me repeat myself. I know it's confusing. Okay, so A punya equation is minus omega squared A, right? That's the basic, X. That is in your book. Okay, what is X? X is A cosine omega T. What is the maximum displacement? Maximum displacement is A to minus A to minus A to minus A. When is what is the displacement of X to make A maximum? Okay, let's look at the graph. What is X to make A acceleration maximum? So maximum is here. What is X? X should be negative A. Okay, X should be negative A. So if I want to make it a maximum, my X should be negative A. Okay, and omega is 2 pi f. That is a basic equation. So A, we already know that. Kenapa saya decide that A maximum should be a positive? Well, actually A maximum can be negative or positive. Tapi untuk menjawab soalan selalunya tanya, what is the maximum velocity? What is the maximum acceleration? Walaupun simple harmonic goes back and forth, negative, positive, but we will always take, this is the convention, we will always take the positive. So even if you decide not to tengok graph tadi, you decide, okay, the maximum displacement for X is A, right? So you get minus omega A. But you know that acceleration goes back and forth. It goes negative, positive, negative, positive. So you said, okay, the final answer is positive omega squared A. Whatever that value is, you give me a positive answer. I accept it because you know that it oscillates back and forth. Okay, so if you can't remember that A max occurs at negative A, you can just substitute A and give me the positive answer. Boleh juga. Okay, sebab sebenarnya it's a negative positive punya situation. Okay, tengok balik equation tadi ya. Kalau tengok sini, acceleration is negative positive A omega squared. So kat sini dia tak directly cakap either it's a negative or it's a positive. But convention, kalau dia tanya soalan, give the maximum acceleration, you give me positive answer. Okay, boleh ya? Just use that equation basically. Okay, I think that's it for today. Kita akan sambung next problem. Banyak lagi ni chapter 9. Oh my God. Okay, so I'll see you tomorrow. Okay, bye guys. Okay, kalau soalan boleh tanya macam biasa. Okay, bye-bye.
Thank you, Doktor.
You're welcome.
Thank you, Doctor.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Thank you, Doctor.
Doctor.
You're welcome.
Doctor,
You're welcome.
doctor,
Yeah?
can I know why the equation of acceleration cosine W T will become X? Is it directly sub the equation?
Can you know why?
So the problem just now.
For the problem just now, kenapa apa?
A, the equation of acceleration equals to negative W square, yaitu dia akan direct jadi equals to negative W square A.
Kenapa equation dia jadi negatif omega square A?
Ya,
Okay, okay. Tadi kita dah derive. Okay, so okay, let me derive it again to make you see. So X is X.
sorry doctor, you can see this.
Oh, okay, sorry, forgot. Oh, sorry. Share screen. Okay, so boleh tengok Okay, so X is buat ke bawah ni. So X is A cosine omega T. Okay, so to derive this, V is the derivation of cosine is negative sine omega T. And then I have to derive the omega T because ada T kat sini. So the omega goes out kat depan ni. So A omega. So equation dia jadi minus A omega sine omega T. Okay, that's your V. And then your acceleration is the derivation of, the derivative of V. Derivative of V, when you when you differentiate sine, it becomes a cosine omega T times omega. Okay, so this becomes A. So this becomes omega cosine omega T. This is after differentiating it, right? And then now your equation becomes, hello, covering block. So now your equation becomes minus A omega squared cosine omega T, right? And you know that cosine goes from +1 to -1. That's the maximum value kan? Cosine, the amplitude goes from positive, negative, positive, negative, positive, negative because it's sinusoidal. So the maximum value that cosine should be is -1 so that acceleration becomes a positive value. Because why? Because A is a constant, doesn't change. Omega also is a constant. The speed is the same for a simple harmonic motion. Kenapa? Sebab dia repetitive over the same path. Dia tak boleh ada perubahan. Dia kena sama je. So kalau semua benda sama je, speed pun kena sama. So A, displacement, sama. Speed, sama. The only thing that changes is the cosine omega T. And the maximum, to make this equation a maximum, the cosine has to be a -1 or a +1 to make A maximum. Because you know cosine can be a lot of values, right? Cosine can be 0.5, cosine can be 0.3. So the maximum to make A maximum, cosine has to be +1 or -1. Okay? And I told you, for convention's sake, your A maximum should be positive. So here, minus A omega squared minus 1, which is the cosine. So that is how you get your equation to be positive A omega squared as your A maximum. Okay, is that okay, Mason?
Doctor, how do we know the cosine omega t will be positive one or negative one when this is maximum? Do we need to read from the graph or we just assume it?
Or we just assume it because we want the maximum. So from this equation, maximum tu akan berlaku kalau cosine 1 atau negatif 1 je. Untuk equation ni as a whole, okay, because cosine can fluctuate from negative 1 to 1, right? Fluctuates from negative 1 to 1. To make this equation the maximum, I have to make my cosine minus 1. Itu je. Kalau tak, dia akan jadi 0.3, dia akan jadi 0.5, which it makes my A decrease. The value becomes smaller. I don't want that. I want it to become the maximum value. So I will say cosine should be negative 1 to make it A maximum. Yes, it is by assumption. You don't have to look at the graph. You just have to look at the equation. But if the graph helps you, boleh. Tapi kita tak provide graph lah nanti dalam exam. So my suggestion is look at the equation. See how can you make it a maximum. What should cosine be to make your acceleration maximum?
So kalau macam ni, can we remember that when we want to find the maximum acceleration, the equation must be negative a omega square in negative 1. Multiply by negative 1.
So to make the A maximum, negative A omega squared. You want to just directly go to positive A omega squared ke? Is that what you're saying, Mason?
Yes.
Boleh?
So
Boleh?
if this one is the zero, we can directly remember the final equation.
Yes, you can directly use this formula, but provided you know what is your A and what is your omega for the question. Boleh?
Alright. Alright, thank you.
Okay. Okay, bye guys. Have a good lunch and rehat.
Thank you, Doctor.
You're welcome.
Thank you, Doctor.
Okay, doctor.
Welcome.
Thank you, Doctor.
You're welcome.